Okay, in the last video, we asked you to consider and hypothesize what's happening when bonds are broken and when they are built. And so to answer your questions and hopefully confirm your hypothesis, when we pull apart molecules, just like pulling apart these magnets, it takes energy investment. So the energy that we use allows for us to open up that bond space and then for the oxygen and hydrogens to bond in those two locations. Hopefully you notice that when these come together, and even in coming together, I don't have to push them. They actually are energized by their attraction to each other. And when they click together, you hear a little sound that's being released, and that sound is a form of energy. In real chemical reactions, and not just in these models, but in our chemical reactions, when those molecules come together, they disturb the environment or transfer energy from the bond that's being created to other things outside of themselves. So, and that helps to energize. So the cool thing, in the last video I told you, I talked to you about fatty acids. So fatty acids have lots of bonds because they're carbons bonded to other carbons, and then every possible location where there could be a hydrogen, we have hydrogens. Looks like we're missing one right there and one right here. So there are a lot of bonds that can be broken. And as those bonds are broken, and there are other molecules sitting around like phosphorus and other carbons and nitrogens and sulfurs. This one's a sulfur, oxygen, nitrogen, and phosphorus, just like our chinops that we've talked about. And then of course we've got carbons and hydrogens. And these hydrogens are pretty easy to get to come off through other disturbances or energy being applied. So I'm going to apply some energy, and then as those molecules start moving, they will easily find other locations to attach to. And so that rearrangement of molecules results in the production of new macromolecules that can be used to make proteins or nucleic acids or lipids or just whatever we need. So one of the really important molecules that we're going to be talking about a lot is glucose. And the reason that we talk about glucose is it's a sugar, and it is one of our major energy sources for our brain. So here's a glucose molecule made up of 6 carbons. I'm not modeling the oxygens and hydrogens that are part of this ring, but there are oxygens and hydrogens. And so in photosynthesis and respiration, we're going to either be breaking down a glucose molecule or creating a glucose molecule. So keeping that in mind, if we're taking in this glucose molecule and we break it apart, that step takes energy. But now we have the ability to start forming other bonds and rearranging and making other kinds of molecules with the carbons that were part of that original glucose molecule. Okay. In photosynthesis, we're going to be taking carbon dioxides. So we'll have a carbon with 2 oxygens. There's our carbon dioxide. And we will take in carbon dioxide and combine it with other carbon molecules, other carbon dioxide molecules. And as those oxygens are removed or rearranged, we can start putting carbons together to make glucose. So we've got 2 different things that we're going to be looking at: the building of glucose and the breaking down of glucose.